Okay, welcome back. We will look at the example to go with day 18, the two-way ANOVA. So I'm going to share my screen with you, and I'm going to pull up my notes, and then we'll look at some Minitab to go along with this. Okay, so I'm on, which page is it? 17 here, looking at example 2. We're going to study tomato plants, and we want to know the yield. So this is like a long-term study, right? It has to be over the season of the growth of a tomato plant. But we're looking at the yield from the tomato plant, so the number of tomatoes. And what we're going to look at is the plant variety, which will be factor 1 or factor A, and the density, so how tight we're going to, or how close we're going to plant these plants. That's my factor B or factor 2 is the density. So when we're reading something like this, we will know that it's a two-factor. It won't be a guessing game. You won't be guessing if it's, I mean, you might be guessing if it's a one-factor versus two-factor, but you won't be guessing if it's a one-factor with a black or just a two-factor. So if it's a one-factor with a black, it will tell you that you're looking at a blacking variable. If it's a two-factor, it won't say anything about a blacking variable, but it'll mention two factors, okay? So it's not really a guessing game. You just have to read and see what it says. That's all there is to it. So here's my nice data, right? So I can see that I have M is 3. It means I have 3 replicates or 3 data values in each cell, okay? So I can see that density, my factor B, has 4 levels, and my variety, which is factor A, has 3 levels. All right, so it's a 4x3 factorial design that we're looking at. Okay, so I just wanted to point those things out. So I'm going to go through this in a minute. I'm just going to look at the write-up a little bit, but we're going to go through getting the descriptive statistics and everything, so we're looking at them separately. So maybe I'll go right on over to my Minitab right now. So I have to stop sharing this screen because I don't think I could just switch. And I'm going to go open up my Minitab, maybe, if I can find it here. Oh, there it is. Okay. So here's my Minitab. So let's take a look at, you know what, I changed my data values. It just said Y, A, and B. I wanted to know like what they were. So it made more sense to me. So I just changed my labels in here. You may do the same if you would like. If we're getting to know the data, I'm gonna do the same thing I normally do, stat, basic, and then descriptive. You don't need to have anything fancy. My variable is my yield, and I'm going to separate this out by variety first. I mean, you could do density first, doesn't matter, but I want to just do one at a time, okay? And the same thing for my box plots. I'm going to do one at a time. So here's my yield by variety, okay? I'm going to do the same thing for the yield by density. Take this out and put my factor B in. So we want to do those separate. Okay, and like I just mentioned, we're going to do the same thing for the box plots where it's separate. So I'm looking at a box plot with groups. I'm going to put in my yield in my graph variable, and I'm going to separate it out by the variety first, and then I'll do this all over again, and I will get it for the density. Man, sometimes it takes a few minutes. Okay. Oh, I forgot to put my mean symbols on there, but that's okay. So we can look at this. Now look at plant variety number 3, how much higher that is. So you know the mean's up in here somewhere. The mean, I wonder if this will even tell me. No. So the mean is definitely higher on plant variety 3 over 1 and 2. We could just see that. That's what this part is all about, just getting to know the data, see what's going on. Because looking at the table, it doesn't always make sense. I'm going to add my mean symbol here because that's what I would like to normally look at since we're studying means. Okay, so here it looks like the density of 30 has the highest yield on average, right? It doesn't look like it's really too far off from 20 and 40, but it's a little bit higher. So that's something I would look at. So if I'm looking at my question, I think it just asked me to do those. I don't know if it may ask me to make a statement, but I could just make the statement. when I'm looking at my box plots, it looks like maybe this density of a 10 has a bigger spread, and it looks like variety 2 has a larger spread. So if I needed to mention anything like that, I could. Now, the next thing I want to look at is my interaction plot. So this is new for us because we haven't had two factors. So I'm going to go to Stat, ANOVA, and all the way down at the bottom, you will see where it says interaction plot. I'm going to click on that. My response variable is the yield. My factors are density. I'm going to bring in B first and then variety A second. It doesn't really matter. It's just if everyone brings in B first and A second, then that way everyone's graphs are consistent across the class, but you're going to get the same reading. I'm going to display a full interaction plot. I don't need to click on options. I click OK. So here's my interaction plots, okay? So this brings it both ways, where I'm looking at plant density and then the lines here, and then I have my variety, or the other way around, where I have my density here and then my variety. So it looks both ways. Now, just quickly looking at these plots, I want to notice that these three lines have the same trend. Now the green one is a lot higher, I'm recognizing that, but they still have the same trend. And same thing for this other plot. All four lines have a same trend. The blue is a lot lower than the other, but it still has the same trend. So if I'm doing a write-up about my interaction plot just to notice what's going on, I will just say something like, it looks like the lines are following a same trend, but I could mention how plant variety 3 has a larger amount here, right, overall, and here I could say that density 10 is lower than the others, right? So we can mention something like that. But what I want to get at is, do I think there's an interaction? And my answer is no. I don't really think there's going to be an interaction between the two factors, because in both of these plots, the lines are following the same trend. So that's what I'm looking at there, okay? But let's actually test it out, right? We're not going to just trust our picture and what we think. We're actually going to test it out. So I'm going to build my model. So Stat, ANOVA, general linear model here. I'm going to fit my general linear model. My response is my yield. And then I'm going to enter in both factors, factor A and factor B. I'm going to ask for the storage for my standardized residuals for my NPP if I want it. And before I click OK, I have to do one more thing. When we build these models, I can't just have A and B. I have to change my model. So I'm going to click on model, and I'm going to add the interaction term, which is A times B. That's what it actually is. So I'm going to highlight both A and B up here on the top. It says interactions through order 2, and I'm going to add it. Now you'll see in the model, terms in the model, I have my factor A, my factor A, or factor B, and then my A times B. Now I can click OK and move forward with my model. So that's something new that we have to do with two factors. We didn't have to do that with the blocking factor, blocking variable, because we weren't really interested in it. But now we have to do that with the second factor here. So this is where I get the 3 parts of the output for my 3 different tests. So my interaction test is this third one, where it's A times B. My degrees of freedom right here, 6, 24. My F is 0.84, and my p-value is 0.5. All of a sudden my throat got really dry. Okay. So if my p-value is greater than 0.05, that means I cannot reject my null, and that is a good thing, because that means I'm not showing a significant interaction, which we thought would be true. Now that means I can go on and test my main effects, meaning I can see if plant variety has an effect on my plant yield, sorry. And then the same thing separately for plant density for my plant yield. So what I would do is, if I'm doing my factor A main effects test, I'm going to look at this. My degrees of freedom are 2, 24. My F is 103.34. That is huge. My p-value is very small. Okay, so I can reject my null. I am showing that there is a difference in means. For factor B, my degrees of freedom are 3, 24. My F test statistic is 18.23. My p-value here is also very small, so I can reject my null. I am showing that there's a difference in means. Now, since I'm showing that there's a difference in means and I have more than 2 levels to each factor, right? One of them had 3 and the other one had 4, I need to do 2 keys. So I'm going to stop here and I will pick up in the next video with the 2 keys.